Alright, so we're going to do a quick tutorial on the step-by-step of creating a tool path for some simple geometry. So these are the elements that we're going to tool path. Our first step is to go up to RhinoCam, and we get our drop down. So we're going to go into the mill command, and so this is the record of all of your tools that you're going to generate. I usually get rid of that just to make some space. So in this area right here, the first thing we want to do is come up to the machine operations or MOPS, and we want to create. We go to this other button here, click on that, and then that's going to give us a MOP set. So we want to click on that, and that's going to generate an area where we can have a single tool path, and then we can generate a separate MOP, or we can have a bunch within that area. So with this guy highlighted, the first thing that we're going to do now is, and we're not going to do it in this one, or we don't need to, but with our program in the RhinoCam that we do, there's a pecking command, but we always use engraving, and we'll just use a dot like that, and we will engrave with whatever tool. So if this was a 1/4 inch hole, what we would do is we would do an engraving pass and have it step down. We'll go through the process on that just to show it. But to start off with, the first thing that we're going to do is we want to engrave all of this lettering that's in here. So first thing we do is go up to machine operations, and we're going to grab or click on the 2.5 axis button, and these are the different operations that we do. Typically what we use are engraving, profiling, pocketing. That's pretty much what we use. Probably 95% of the time, 99% of the time, those are the 3 tabs that we'll use. So to start with, we're going to do an engraving pass. The first thing we want to do, so what as a rule of thumb, what I typically do is I'll go through all of these tabs. So you want to remove, as you get into the different tabs or different tool paths, some of these guys might be highlighted. So the first thing that you want to do on every one of them is remove all. In case there was one highlighted, this will remove it, and then you go down to select curves and edit regions. Click on that. That dialog box goes away, and you can see here it's waiting for you to put in commands. So just go through and highlight all of these. I'm holding down my shift command, and I'm just clicking on windowing over all of these guys. So those are all the regions. Now what I'm going to do is I'm going to right click, and you can see there's all my regions. So however many was, looks like there's 81 regions in that. So now what we do is we're going to go through all of our different tabs here, and we're going to go through tools, or go to tools. So you're going to designate and name the tools that you want that you want to use for this. We typically default, we'll use a V cutter, like a 45 V cutter. You can use whatever V cutter you want for your engraving. You can use a ball mill if you wanted to, if you had a small one. But we're going to use a V cutter. I typically put that in tool number 7. So I'm going to click on these guys right here, click on this dialog box, or just click on this guy, and it's going to pull up the naming of the tool. I always name the tool because what you put in this name box here is going to show you, it's going to identify within all of your when all of the different tool paths are generated, what tools are being used, so you can quickly look at it and make sure that you have the right tool name for that. So we're going to click on either one of these guys. You're going to name the V cutter. So we call it V cutter, and then name the tool, capital T, and then we always put our V cutter into tool number 6. You can put it wherever you want. It's just, this is that visual that you want to have, so when you have your showing all your tools, that one that I turned off at the beginning, it's going to show you what tool that is. Diameter doesn't matter because it's a V cutter. I'm just going to put 0.125 in there. And then the other really important thing, this thing is important. You could have this missed name, but it's not going to matter. The diameter of the tool when you get onto other ones is really important, but the most important guy here is the number. So that's tool number 6, because you're telling the tool changer where to go, what tool to grab, and what size it is. So save as new tool, click on that, and then hit OK. So now you can see here it's showing you 1/8 inch bit, tool number 6, and tool name, V cutter T6. All right, we want to go to our next tab. So like I said, you're going to go across here tab by tab and work across here till you get to the last one, sorting, and then you're going to hit generate. So our next tab is our feeds and speeds. It just defaults to these guys all the time. Some routers don't go above 18,000. Ours goes to 30, or one of our machines goes to 30. We're going to spin this V cutter at 18,000. These guys here, these are the you can see by plunge, approach, engage. Those are the different definitions of the part as it's going in and making its cut, and then its retraction. So I typically just go 75. I might even do the engage. Actually, I'll do the approach at 50 and the engage at a little bit slower, maybe 30. And my cut feed, these pieces are a little bit bigger, a lot of tight angles and stuff like that. I don't want to go too fast, so I'll probably put these guys at the 75 range also. You can mess with those based on how you feel it's cutting the machine, or cutting on the machine when you do it, and make the alterations based on how big your letters are, and how many just smooth curves there are versus direct changes in X, Y, and Z, or the X and the Y. Retract 75. So clearance plane. Your next tab is your clearance plane. So it defaults to an automatic, which is just a skim across the top. On a flat sheet, you could get away with that. I typically default just to a 25, 0.25 over the top of the part. When you're getting into 3-axis milling, or if you have tabs where you're holding stuff down where things might be higher, you want to use this tab to adjust your height so that you make sure that you're going up and clearing over the top of your parts. But I default to 0.25. So moving on to the next tab. So this is where we're telling the router how deep to go, and if you need to go in different steps. With the engraving pass, we're just going to go like 0.02, 0.03, depending on how deep you want the V cutter to go. On the V cutter, I usually go like 0.02, but you can make the adjustments based off of that. So total depth of cut, 0.02, and if you just click on the rough cut, it's going to take that value and just place it there. You could, if you wanted to, you could do a 0.02, and then down here do 0.01, and then what it's going to do is it's going to do these letters twice to get to that value. There's no reason to do that, so I'm just going to go back to 0.02. All right, so we have this is something for a later. This is a valuable tool, but use the default of the all top. This has a lot of great value, but we'll get to this in a later video. So you've got your depth of cut is 0.02, so it's just that V cutter is just going to go below the C plane, 0.02. Your exit and your entry. This is a good tool. Exit and entry. The control of this is good to have later on when you have non-mortising end mills, or things that you want to come in at an angle. We'll get to that in a later video too, but we're just going to, because it's a V cutter, we're just going to go straight into the part. So vertical distance 0, 0. Let's go to the next one, advanced cut. Don't need any of this stuff. This is all for a later video. And then sorting. This guy's no sort. It's just kind of randomly go wherever it wants to go. So what I'm going to do is I'm going to click on. Well, let's show you what it looks like here. So no sort. We're at our last tab. So let's go ahead and generate it. That one did a pretty good job. But what I'm going to do is I'm going to open this guy back up. Go to parameters, and go to sorting, and then minimal distance. So what it's going to do is it's going to I'm curious to see how much different it is if it's not going to do some of these guys around here, but let's try it. Minimal distance, generate. A little bit less. I don't even know why they give you the ability to be able to change stuff like that, because you want to go the minimal distance anyway, but I like what this one's doing. So that's your first tool path. We've engraved this lettering here in the top. If we were going to go, let's go ahead and do it. I'm going to drill a hole. All of these other holes have just a circle drawn. If this hole was 5/16 and you didn't have a 5/16 end mill, you could go in here with a 1/4 inch and do a profiling pass and have it enter the part in like that. In fact, I want to do that so we can show how that would work. So let's go to we're going to go back up to our 2.5 axis milling, and we're going to do profiling, and we're going to do remove all regions in case any of the other ones were highlighted, and then we're going to select, and we're just going to click on this one circle here. Oop, it's a half a circle. Let me start over. Whoever drew this did it in 2 half circles instead of a single circle. So let me join that together. Join, so we should be a single circle now, which we are. And I'm going to measure this guy across. That is 2.6. So what I'm going to do is I'm going to, instead of hitting this with a 1/4 inch, I'm going to do this with an 1/8 inch so you can see how it works. Let's go back up here to 2.5 axis milling, and we're going to go to profiling, and let's go remove all, create a region. I'm going to click on that. I'm going to right click, and that gets me my region, and I have that single region. So now my next thing is I want to tell it what tool. So I'm going to click on this guy again, and I'm going to go to the end mill, and the tool I'm going to generate now is a 0.125 end mill tool. We'll do that tool 3. And so really important that you put the tool diameter 0.125 and the tool number. You don't want it to go grab the wrong tool. Tool number 3. Save as new tool and hit OK. Feeds and speeds. We're going to go back to, I'm going to spin this guy at 18,000. This is where we're going to, I'll show you the feed rates, I mean the entry and exit tools. Let's go to plunge. I'm going to go 75, 75, 75. I'm going to keep this one kind of slow. I don't want it to, because it's going to ramp in. I'm going to do that one. Actually, the engage, I'm going to do 50. And the cut, I'm going to do 50. And then the retract and departure, both of those will go to 75. Clearance plane, once again, 0.25. It defaults to that once you start using it a couple times. So I'm going to leave that. This guy here, global tolerance, what this is going to do is, this is in Rhino or most drawings, a curve is not a curve. It's a series of segmented lines that create a curve. So the tolerance on this is 0.0, and if you're cutting something like plastic or something like that, and you're cutting a curve, and this is say this was 0.01 instead of 0.001, you'd actually see the straight segments to create that curve. This is a good one to default on. If you need it to be smoother and you notice that, you can always add a 0. It's just going to add, it's adding more geometry to the toolpath, which takes it longer to toolpath. So this will actually be fine for what we're going to do. This stock command, if you needed to cut a little bit deeper in beyond, because the tool is going to come in here and it's going to move inside of this line to cut the, or to leave you that yellow region or that hole. If that hole wasn't quite big enough, you could come back in and say do a 0.001 or a 0.002, whatever the tolerance was, and then it's going to cut a little bit deeper or negative. You would do a negative stock, so a negative 0.001, whatever tolerance. or you could do a plus if you wanted to sneak up on it and have it not cut quite directly to that. But we're just going to leave that as a zero tolerance. These are the generation. So conventional cut, because the bit's spinning this way, if I travel in and enter like this, it's a conventional cut. If I come in and go this direction, it's going to be a climb cut. We're going to leave it. I'm going to go ahead and click on conventional. This will be for a later. This is if you want to sneak up on something and cut in and then step over and then do a finish cut. There's times where that works out really good, but we'll do that on a future video. Our cut levels. So now this piece that we're cutting into, this piece is 1/4 inch material. So what we're going to do is we're going total depth of cut. I'm just going to put in it because we have a max depth setting on our router. So we're going to go 0.26. And if you wanted to say this was 3/4 inch material or 1 inch material, and you wanted to do different layers or different levels of this, you would tell it. You would tell it here that in the roughing pass, I want to do X is how deep of a cut it would do to generate this and to give you a finished pass. If you're doing a bunch of holes or a bunch of circles, you want to have leave an onion skin. These are the commands that are going to give you the ability to be able to do that, and we'll do that in a future video. But for right now, this is 1/4 inch deep. So what we're going to do is we're going to, on our rough depth, we're going to go because we have an 1/8 inch cutter, I typically don't go any deeper than the diameter of the bit. So what I'm going to say here is I'm going to go 0.1875, and you can see that it puts that back in there as a single pass. But what I want to do is I want to do that in I'm going to do this as 0.09375. So it's going to do 2 passes at that to generate that, and then it's going to do a single pass at that. This is probably overkill, but you'll see the control that you have, the value of that. This guy here, if you're cutting out a bunch of items and you don't want those to break free of the vacuum or you want to do all of your cuts on one level. So if you had a bunch of these guys and you wanted to do all those first and then come back and do those again, leaving an onion skin, and then do a final pass with that tiny little bit so the bit isn't being loaded up, then you would hit level first, which is going to do all of the parts there, and then go go all of them at that first cut, and then go back and do the second layer at that, and then do a final pass. We're just doing this one hole, so we're just going to leave it like that. Entry and exit. So you can see it defaults. You got to make sure that, especially if you have parts nested right next to each other, that you don't leave this command on, because it's going to default to, it's going to enter the part out here in a straight line and then radius into where you want it to cut. And if you have a part next to it, it'll end up cutting into that part. So what I do is I either do none, which means that the tool is going to enter straight down in and then make its cut. Because I'm going to be using an end mill cutting into some material, I want to enter in at an angle. So I'm going to do a long path. So I click on that guy, and you can see by the diagram here that it's entering. You've got your entry, your angle, and it's going along the path. The light blue line, which is the center of the tool path, is where the center of the tool is going to enter. So our a long path angle, that's with the pink line right there. That's pretty steep. I'm going to do this guy at a 45. And along the path height, because I always like to make this dimension bigger than the one right behind it, which is the depth of the cut. So I think we did 0.09375. I'm just going to do 0.125. So that's, and then also really important is I want to click this box here. So what it's going to do is it's going to enter and make that cut, and then it's going to raise up and then enter back in again. Otherwise, it's going to enter at an angle, and once it gets to the final part ready for the next part, it's just going to drop straight down in. A lot of times if you have a plunging end mill, you can get away with that, but it's also really good to be able to have the tool remove itself and clear any dust and stuff that's in there, and then re-enter in an angle again. So what I'm going to do is I'm going to hit apply entry exit to each level. Click on that guy, and then you can see, because I'm still on lines and arcs, it's going to enter the way we told it to, but it's going to exit and come out of the part. We don't want to do that. So I'm going to hit none, and now once it hits the end of its rotation, or end of its tool path, it's going to raise straight up out of the part. Advanced cut parameters, none of this stuff is really applicable for this tool path. Corners, no, and sorting, no, because we have that single. So what we want to do is we want to hit generate. So you can see what's happened here is the light blue line is on the outside of the hole that we want to cut. But you can also see the pink line is the entry, so it's entering at a 45-degree angle. So it's coming down just above the part, because I told it I wanted to be 1/8 of an inch, and the depth of cut is 0.09375. So it's entering above the part at an angle. But what we want to do is we want to get this guy to cut inside of this hole, because we're trying to cut a hole, not trying to cut a little plug. So what you want to do here is you want to go up to your command line, which is there, and type in flip, enter, and you see what happened to our tool path over here. This is we got this red star, which means that you've changed something, and it's warning you that something's been changed. So but that's what we want to see. We want to see that red guy there. If you click on that, and then so we hit flip and then enter, and then I come over to here and I hit regenerate, and it moves it to the so what it's doing is it's flipping the tool path to the other side of that region that you created. But this is the way we want it to do. So it's going to come in at an angle as it's cutting into the part, and then it's going to go around. Remember that the tolerance that I told you about. So we go back to parameters. See this tolerance right here? That's that light blue line. You can see how it's line segments like that. This is a pretty small curve, but you can see these straight lines. So let's go to, I'm just going to add a 0 to that. So now you have 0.0001. Let's hit, now watch, when I do that, watch these lines here. Turned it into a curve that's really, unless you zoom way in, now you can see those, whoops. You zoom way in, you can start seeing that those are straight lines also, but that's that tolerance level. All right, we'll just leave it at that. So that's how you handle a single hole. Let's go to if you're cutting a hole that's a different size than the end mill that you want to do. But this guy here, we're going to drill these guys. The hole was a 2/6. If this was a 1/4 inch hole and we wanted to use a 1/4 inch end mill, what we would do is we'd go back up to our machine operations, 2.5 axis, go to engraving. Once again, hit remove all, select curves, click on that guy, and then I right click, and there's my one region. So then you go back through your tabs, hit my tools. I've already got this tool named, or no, I don't. So I'm going to name another one here. So I'm going to hit 0.25 end mill tool 5. Tool 5 is always what I put my end mills, 1/4 inch end mills in, and very important that you change the diameter, 0.25, and then tool number 5. Save as new tool, and OK. Same deal. When I'm doing a drill, or when I'm drilling out a hole, but using engraving, you don't want to be spinning. You want to go more towards, you want to slow things way down, because you'll generate a lot of heat, and the bits just cut better when they're spinning slower, like a drill press. So I usually, if I'm drilling, I'm going to go down to 7,500. That feed rate's good. 75, 50, 30, 75, 75, 75. I'm going to slow it down a little bit. 50. Clearance plane, 0.25. Cut parameters. So depth of cut. This is 1/4 inch material. So I'm going to tell it to 0.26. We can tell a little bit more because we're going to set our max depth so we don't go into our spoil board, or we can determine on the CNC how deep into the spoil board we're going to go. But we're telling it 2.6. I don't want to do this all in one pass. You could do it in one pass because it's only 1/4 inch thick, but say this was 1/2 inch or 3/4, you'd want to do it maybe a 1/4 inch at a time. This one, I'm just, for sake of example, I've got 2.6 as my total depth. Half of that, 0.13, and go to exit and entry. If I don't click this box right here, what it's going to do is it's going to just go down 0.13 and then not retract, and then go back down 1.3. If you're using an end mill, just an end mill, you want to clear the space of this and get the sawdust out of it. So by having the bit retract and then go back down in, then you're going to be able to clear any debris that's in that hole. So by clicking that, it's going to go 1.3, and then it's going to come out your clearance plane, which was 0.25, and then it's going to go back down into the part again. Advanced parameters, not necessary. Sorting, not necessary. So let's hit generate. So there's your tool path there. You can't really see the step in and out because it's in a single Z plane, but it is there. All right. So the next one that we want to do is just cutting out the perimeters of these guys, and this is 1/4 inch material. Yes. Okay. And one of the other things you want to make sure that you do too in the very beginning. So say one of these parts, say one of these letters or something was raised up. Let's do this. Let's take it up there. Now watch what happens over here on the engraving. When I raise these parts up, when I raise these couple letters up, see how that turned red? That means that if you're looking at this straight down in top view, you can't tell that all of these aren't at the same level. And if you were to, let's go back and see what happens here. Those two letters there are much higher up off the top of the table. If I click on this guy and do regenerate, let's do here and then regenerate. You see what happened here? It took all of these guys are down at the C plane, but it thinks that these two letters are up high, so it's going to cut those up here. It's not even going to touch the top of your surface. So what you want to do, in the beginning, if all of these things are all of these operations, which these are going to be on your C plane, which is the top of your piece of material, then you want to come back in and you want to grab all of this stuff, and you'll see this guy's going to have that red star that's going to show up again once I do this. But I'm going to go to top view, and I'm just going to do project to C plane, and it asks you delete input objects. Yes. Hit enter. Now if we go back and we look at these guys, all of those are back down on the C plane. So now if I take this, right click on that, hit regenerate, all those go back down to the C plane. These guys must not have been on the C plane when I was doing it before, but now they are. And that one too. Right click, regenerate, everything's on the C plane, so we're good. So now let's do the last step of this, which is cutting these parts out. So I want to go back to here, go back to my 2.5 axis milling, go to the profiling pass. Once again, remove all, select new objects, and I'm just going to, so these weren't, I'm just going to join all of this stuff. So I'm going to go to my join command. So now these guys are closed curves. All right. So let's go to, actually I'm going to redo that guy. let's redo this. Didn't like something I did, so click on that, on there. So I'm going to highlight all my regions. Right click, those are all my regions, and then generate. Alright, so we're good. We got rid of that red. So now I want to go and I want to cut out these parts. So back up to my 2.5 axis profiling, remove all, select, and so I'm going to select these regions that I want to cut out, right click, and then go back in and grab a tool. So these guys will probably cut these with a there's enough space between them, we can get away with a 3/8 compression. So I'm going to right click on that, put in 0.375 compress.